Welcome to Deep Engineering's YouTube channel, where we bring you real-world insights from the engineers and architects shaping modern software. Today, we are speaking with Tony Dunsworth, database administrator and data scientist at the City of Alexandria, working in the public safety domain. Tony holds a PhD in data science, and his dissertation, determining the efficacy of automated forecasting models for primary 911 public safety answering points, examines the applicability of zero-shot forecasting tools in high-stakes, time-sensitive environments. For the past 15 years, Tony has worked in the back end of 911 emergency communication centers, focusing on every stage of the data lifecycle, from engineering and database administration to applied analytics and operational forecasting. He's now applying that experience to solve critical problems such as addressing staffing gaps, reducing call volumes, and training the next generation of analysts to use their technical skills for community impact. And he's here with us today to talk about how to build AI systems on a budget using open models and lightweight infrastructure, and how synthetic data can enable secure, privacy-preserving analytics and training in sensitive domains like emergency response. So a very warm welcome to you, Tony. Thank you for being here with us today.
Thank you for having me, Divya. I appreciate it.
Okay, then. So let's get started. The first part of our discussion, we are going to focus on architecting AI solutions on a tight budget. Like you have said before, you are currently exploring building useful AI and analytics tools with limited resources, leveraging open source models and low-cost infrastructure. Can we talk about that, but through the lens of the major part of your work, which involves public safety? Now, as we know, public safety agencies often have minimum tech budgets and few specialist staff. For example, roughly 75% of US 911 centers run with only 2 to 5 people on duty and limited resources. Given these constraints, how do you identify and implement AI solutions that are both useful and affordable?
I think centers have to find their own specific pain points. Each one has its own type of immediate thing that they feel they need. And there are a lot of companies that provide solutions and focus on that space. One of the biggest spaces right now is intercepting non-emergency calls. In the United States and in Canada, when you call 911 or you call your local non-emergency line, you're going to the same pool of telecommunicators. So one of the things that we're trying to do is how can we take some of those calls for, especially for non-emergency services, and find ways to reroute them so they don't get through. If we have fewer calls coming into the center, fewer telecommunicators isn't as big a deal. My dissertation, for example, identified different libraries such as, that LLM, like LLM based or neural network based libraries that could be deployed with minimal technical resources. If you just knew how to write 5 or 6 lines of Python code and could see somebody show you how to write the right import statements, you could get those forecasts that you needed. There are other products like Blue Sky Analytics is an R-based analytics platform that is drag and drop or menu driven. So you don't have to know as much about how to program in R, as long as you can tell it, here's the variable I want, and I want the summary of it. It can produce that for you in 2 clicks. So you don't have to have the same programming logic. So a lot of it is, where do you identify what you need first and what's out there that you can use to leverage your budget the best way possible to get to that.
Right, right. And Tony, can you share an example of where a specific budget-friendly analytics or ML tool made a difference in emergency operations?
Blue Sky, because I've recommended it to some of my colleagues before, where you can load a data set and then just clicking through menus, tell it what you're looking for. You tell it, I want a bar graph of the number of calls that we've taken in this time period. And I want to know, like, say, I want to know how many calls we've taken in a month. You can see how that goes. Or I can say, how many traffic stops have we executed in the last 3 weeks by week? So you can, and then look at that even further and say, tell me they're located. And through a couple of clicks and a little bit of looking through the tech, you can easily get those pictures and you can see a better profile of your data. So you can see what your data is telling you.
Right. Um, so over the past year or so, of course, open source AI models have quickly sort of narrowed the performance gap against proprietary giants, while also offering advantages in cost control and security. Um, to what extent has this trend influenced your approach to building AI systems? Uh, for instance, are you leveraging open source libraries or models to avoid expensive vendor services? And what benefits or trade-offs have you observed in while doing so?
I've built two AI labs. I built one personally that I use that's I'd say is a little more forward thinking, a little more pushing the envelope. And then I've built one in our environment at work that I'm more conservative with. But leveraging both of those, it gives me better control of, like you said, the cost. So I'm not accidentally running up a large bill with some model provider because I didn't realize I'd run out of tokens, or I didn't realize that I had pushed the model to limits it wasn't expected to go to. And I try to be creative. For example, I may use models in my personal lab that I can't use at the office due to some underlying security concern, but it'll give me a focus on what I can work with. The biggest trade off is understanding that the speed is going to be a lot slower. Even with my lab having 24 gigs of RAM or my office lab having 32 gigs of RAM, they are still noticeably slower than if I'm using an offsite LLM to do the similar tasks. So you have to model your trade-off, because I have to also look at what kind of data I'm using, so that I'm not putting protected health information or criminal justice information out into an area where it doesn't belong and where it could be used for other purposes. So the on-premises local models are more appealing for me because I can do more with them, because I don't have the same concern of the data going out of the network.
Right. And I think that brings us very nicely to our next question, where I was going to talk about open models, um, using open models internally that can help with data privacy and cost. And these models can also be optimized to run efficiently on local hardware, letting you keep sensitive data in-house and save, on cloud costs. Um, have you already taken advantages of such approaches in your work? For example, have you been able to fine tune smaller open models or use lightweight ML frameworks on premise to deploy AI without requiring uh, too much, high end hardware or high cloud bills?
Um, yeah, right now I've been doing more of the work with lightweight or smaller LLM models, because they're easier to get ramped up with. They're easier to go ahead and get something that I can put into a test lab and expose to people and say, okay, let me know what this is doing for you. Is this meeting the needs that we've previously discussed? Um, and a lot of our development targets right now have been relatively small, so they don't require as many resources, both size wise or resource wise or token wise. I'm interested in working on quantizing models a little bit better so that I can try to use larger models and have a bit more experience with some of the larger models because some of them are very promising. I have to be cognizant of my environment, knowing that I have definitely some restrictions in my environment, but I've also got to take and build my own knowledge gap. And, you know, I use resources like Pack Publishing. I have a subscription, so I use a lot of the different access to tools and materials to help, and I other tutorials around the way so that I can get better at handling that type of programming. I'm relatively new to it, so I'm learning I'm learning as I go along on how to better leverage my own engineering skills to improve the performance of those LLM models so that I can do more with them.
Okay, and just can you, for those who may be interested in learning, can you like briefly tell us what you mean by quantizing as a way of optimizing?
Quantizing is a way to optimize an LLM by making it work more efficiently with fewer resources, less memory consumption. Um, it doesn't leverage all of the parameters at once, so it's able to package things a little bit better, and it packages your requests and the tokens a little more efficiently so that the model can work a little faster and return your responses or return your data a little quicker to you so that you can be more interactive with it.
Okay, brilliant. Thanks for that. Um, Now, even as open source AI becomes more capable, experts still talk about challenges around scalability and enterprise grade reliability for these tools. Um, what kind of obstacles or failures have you encountered so far when employing open source or low cost solutions in a mission critical setting?
The biggest challenge is resource base. Unfortunately, none of us have infinite resources. I wish we did. So running into a situation where a model bogs down because I'm pushing the model hard for something, and at the same time I'm pushing the resources the model's running on very hard. It gets frustrating, and that's one of the reasons I'm trying my hand at learning at quantizing models in my personal laboratory, because I recognize that I've got to make my work more responsive to my users, or it's not worth it. And that's one of the biggest frustrations is when I can get it where it's working reasonably well for me, and then I turn it loose to a test group, and it doesn't. It seems like it doesn't work at all for them because you feel like you've put all this time into it and it's not doing the things you promised it will do. So the other big challenge is upkeep, and that is, do I reevaluate my models? How do I retrain? Do I bring in a new model that uses less resources and retrain it and go through all of that process again? And continuously reevaluating my work and the work of the model behind it. How is that working? How do those together well? And am I stressing my resources? Am I actually working? Am I getting the coding right to where I'm delivering what it is I'm intending, and making sure that I move my data and use my data in the best way possible to augment what I can do with the model. So there's always a
Mhm.
little bit of challenges. It's not really enough to build it. I've got to take care of it too, and I have to plan for upgrades and enhancements because once the users get a hold of it, they think of things that I haven't thought of, and they say, "Well, can you get it to do this?" And it becomes a whole iterative process. How do I start? How do I take those and fold those into the next round?
Right, right. Um, and how, I think following up on that, what are some strategies perhaps to ensure that an inexpensive solution is still reliable and maintainable? For example, that a prediction model will perform accurately under real emergency conditions, or that a homegrown tool will be supported in the long term.
The supported in the long term is an educational experience.
Mhm.
Right now within the city, I'm probably at the vanguard of doing things with programming AI models. We've adopted some external software that allows us to have some AI interaction as we stand right now. But as we push to what we can do, I'm starting at the vanguard of programming and writing more of the scripts and writing more of the programming. So the the challenge is finding the colleagues that are interested and then getting the time to work with them to show what I've done, listen to their experiences, see what they're doing or what they're interested in, and then putting that together so that we can start building a team that advances that a little further. And that's always a challenge because we all have our day jobs, and this isn't necessarily our immediate core function. So finding that time between and how do we work it into our core functions so that we can spend more time working on it and building new things that we can then show to the city and say, these are the things we can do. And if you give us a few more resources or more time or more of an opportunity, we can do even more.
Right. Brilliant. So that brings us to the end of the first segment. Um, so now let's move on to the next segment of our interview, where we are going to talk about synthetic data for high stakes domains and something that Tony has been specializing in of late. So in high stakes domains like emergency services, real data sets, for example, not 911 logs, are often sensitive, proprietary, or too scarce to use freely for AI development. Um, let's talk a bit about how synthetic data, that is, artificially generated data sets, can address this problem. Um, so, what strategies do you currently use to generate synthetic emergency call data that preserves the important real world patterns? For example, do you rely on statistical simulations, generative models, or other open source tools to create call records or incident scenarios?
I start with I started out a long time ago working with a commercial product, and I started kind of using one of the things that they suggested is I take a real data set and I take it apart because I'm also the analyst that works with that data. I take it apart and I find the things that I need to see in it. For example, our center is a combined center, so it answers for police service, fire service, and medical services. So I look at the ratio of the calls that we receive so that when I make that data set, it reflects that it reflects that those ratios properly. Or I look at the reports that I currently generate that I want to transition to maybe AI generation, or I want to be able to automate in some fashion. And I look at that data. So I use real data as a seed insofar as I find details about the data that I then want to recreate. And for me, it's a lot of statistical recreation. The generator that I'm working on and I've built now is it's all Python. It's all open source scripts. But now that I have that down fairly well, I can now feed that into an AI model and say, okay, I need you to examine this. This is where I made a lot of progress. I fed it into my local model and say, okay, this is the generator. What can we do with the data that it comes out of, and feed it prompts and feed it questions and say, let's massage the model a little bit more so that you can generate that data set based off of these parameters. And I've gotten some really interesting results that have been they've been pretty positive. So I start building, kind of in tandem. I build a lot of it and then I pass it off to my local models to see what it can do to refine what I'm working on to make it a little better. And I think between that, it's made it to where I can generate fairly realistic data sets that I can use in many different places. I use it in testing my analytics models because I can do an analysis of that data set real fast and I know what I'm looking for. And then I can have my model doing the same thing. And I make sure that they match, so that if it tells me something that I didn't see, I go back and I recreate it. Is it there? Or is it something that I need to work on because maybe my model isn't as accurate as I thought it was? So now I can trade off. One of the biggest challenges was when I first started building data sets, a lot of my elapsed times between events, because we calculate how many seconds it takes for between this event, between one event and another, we're all normally distributed. In real data, it may be exponentially distributed, it may be log normal, it may be a Poisson or a gamma distribution. So I'll run tests against stripped data to say, okay, I just want the numeric variables. I don't want the header, I don't want anything else. I want just the numeric variable, and I'll written a script that analyzes the distribution and compares it, and then tells me, hey, here's the distribution, here's its details, and then I feed that back into the model and say, okay, make sure that you're using this distribution with these parameters when you generate these elapsed times between events.
Right. Um, okay, so moving on from that, government and industry groups have started emphasizing that synthetic data is a key privacy preserving technique. For example, a 2023 federal strategy noted that synthetic data can unlock the beneficial power of data analysis while protecting privacy. Yet it also noted adoption has been slow due to limited awareness, lack of standards, and concerns about quality. In your experience so far, what are the biggest hurdles to using synthetic data in practice?
The biggest hurdle was pushback from peers at first. When you start presenting synthetic data, the reason for me when I started using it for presentations and in instruction was I didn't want to lose my audience if they recognized an event. So when I explained to them this is all synthetic data, they kind of looked at it like, well, looks correct. So we started taking it apart, and that's when we found the challenges that I identified earlier with
Mm.
normal distribution in places that shouldn't have it. So as I have reiterated, as I've iterated over time in the generators, the way I do it, the closer I bring it to a real data set into it. And they're like, oh, wait a minute, can I use the generator so that I can give a presentation without exposing real data? Yeah. And explain to them how to use the generator, what the data output's going to look like, how to do things with it. And now people are more interested in just a couple of weeks ago, I had a company say, hey, have you thought about using that generator for this purpose? No, I hadn't, but you guys can clone it. I've got it, it's a public repository. You can clone it and you can start working with it, because keep it under an open source license. Just give me the improvements back. That's all I ask for. And I'm starting to see more people are interested in finding ways to use synthetic data so that we can preserve that privacy, but we can also advance what we're doing. And a lot of what
Mm.
I'm seeing now is in training, in teaching, and in testing, especially testing now, because if we can generate a data set, we can generate just even pieces of the data set that we need, and then plug that into the application to test the output. We now have a way of doing that is much more secure, much safer, but it gives us real results because now that data is more realistic.
Right. And looping back a little bit, have you faced any challenges when it comes to validating models trained on synthetic data, and how they will perform on real world data? Have you faced any of those kind of challenges that you'd like to talk about?
Thankfully, not yet. Actually, I've been pretty successful. I think that the closer that I've made my data sets to as realistic as possible, the better I've seen the actual model performances behave. When I first
Mm.
started, yeah, I've got some really weird output, especially when I'm trying to build models that look at data analytics, because one of the things that we want to do is I want to take and improve the use of analytics in centers. So I want to make it easier for analysts or for people to analyze data. And I found that because my models weren't as realistic as I thought they were, the output obviously wasn't as accurate as I would like it to be. And so I found programmer challenges more than I found application challenges, because I found that the old saying, garbage in, garbage out. And when I was giving it certain types of data, it was giving me back exactly what I would expect, but it wasn't what I needed. So
Right.
seeing how the output wasn't what I was looking for helped me refine my models, and it helped me refine my overall analytics goals.
Mhm. Right. And like you mentioned before, when training staff or demoing new tools, you never use real 911 call data, only synthetic data to avoid exposing sensitive information. Um, and you've talked about how you've dealt with the challenge of skepticism, maybe within your team or the people you work. But when it comes specifically to trainees, who are just starting out, or decision makers, how have you found their reception has been to the idea of using synthetic scenarios for learning?
Um, for the people that are for people that I'm training, once you get over the initial explanation of this is why we're using synthetic data, they're usually on board with it. Decision makers are a little more cautious because they say, well, I want to make sure this is as realistic as possible, because if we're going to do this, we need, over time, as you show them what you're working on and you show them how it comes out, they are the ones, they're a little slower to come on board with it. But once they come on board with it, everything else melts away, because once they're convinced that this is the right pathway, they advocate as strongly or more strongly than I do. So now that resistance melts. But usually for folks, especially when I'm training in analytics, usually for them it's like, okay, you want to see what the worst, you want to see some of the nastiest things we can put to you to see what you can do and how well you perform. All I have to do is change a couple of things in the model, and now you tell me. And they're like, hey, this is great, because now I can focus on a solution. I can focus on a specific area that I want to work on or that I need help with, and I can make sure the data gives me that challenge, as opposed to waiting for events to line up correctly with real data. So it
Right,
becomes a lot easier, especially in the training, when you're training programmers or analysts, because you can really hone in on what you want them to focus on.
right, right. Um, and what safeguards or best practices would you say you follow to ensure that nothing about the synthetic data uh, inadvertently results in a privacy violation or duplicates an actual incident in an identifiable way?
I do two different things. One, I know I follow a lot of the ethical guidelines that I was taught. I was very fortunate throughout my education, through my software engineering courses, my analytics and data science courses at university, that ethics was stressed as one of the most important things that we needed to focus on alongside practice. So I have a very solid ethical programming training. I studied for the certified ethical hacker exam years and years ago, and took the practice exams and passed them. So I have a good background in knowing how to do things in an ethical way, and I keep a hold of that. The other thing that I do is I'm careful about where I pull seed data from. I'm careful about what kind of data I'm reproducing. For example, I don't reproduce narratives that come with calls, because it is too close. There'd be too close to maybe a triggering event, or too close to something that would come out and look like the right type of information. So when I'm working with tabular data, I'm very narrow and very specific about what I do. I also double check when I get output from, say, I use a Faker library to generate names. I make sure that I go through my own list of people that I know to make sure that name doesn't show up as somebody that I might know. Because, yeah, John Smith would be fairly standard, but if I got a Tony Dunsworth accidentally generated from the Faker library, I'm going to say, whoa, wait a minute, we're going to redo this because I don't want to see my name in there, because now it may be too close. Now it's too close because now it's a name I recognize. The
Hmm.
other thing is I've started reviewing different frameworks like the NIST framework that we talked about in an earlier conversation, so that I can make sure that I'm incorporating even more safeguards and rails into my practice, so that I can guide my development processes more efficiently, to maintain ethical standards, to maintain privacy standards, and to make sure that I practice everything as tight as possible. I've talked to my colleagues in the private sector, and I see that I'm not the only one that does these things. My colleagues in the private sector seem in the AI sphere are doing the same things. So I feel confident that the people I work with, whether it's public, private, or whether it's within my organization, that we're all operating from, we're protecting as much information as we can, leveraging the metadata out of that as best we can, but making sure that we're not exposing anything that we can't expose.
Yeah, brilliant. Thanks for those set of best practices. And that brings us to the end of the second segment of our interview. Um, in part three, we're going to talk about risks, lessons, and future directions in public safety AI. Um, so let us take a step back to consider the broader perspective, managing risks and looking ahead at the future of AI in public safety. Um, Now, deploying AI in emergency services carries very unique risks, from technical failures to ethical concerns, but also promises new capabilities. Regardless, introducing AI into emergency response is undeniably a high stakes initiative. Lives can be affected uh, by a bad prediction or a system glitch. How do you approach risk management for AI tools in such a critical domain? Um, you already talked about NIST's AI risk management framework, specifically when it came to privacy. But what about other kinds of risks?
Um, One of the biggest risk mitigation is starting out from the beginning, knowing what you want to use AI for, and how you define how it's working well, and how do you handle the data in transit. Where is your, what data sources are you exposing to the AI, and what is it going to do with the data? How is it going to use that data? And if that data is, are you feeding that data back into model training at the same time? And is that data staying within your organization, or is it leaving your organization? And like, for example, even if I build an AI in my organization, if I'm leveraging an off source model, am I feeding that data back to that model? What data am I feeding, and how do I work with that vendor to make sure that what I'm feeding it is being used in the way I'm intending? I prefer to keep my training in house, so that if I'm training my model off of my own data to improve its accuracy, that doesn't leave my organization. But that's a personal preference, um, because I don't want to expose that risk. So a lot of it has to come down to, how do you define success, or what are you using it for? If you're using it just to say, well, we're using AI, I'm going to be the first one that holds up my hands and says, no, stop. We're not going to do it just for the sake of doing it. But if we have a defined use case and we have a measurable success rate, so that we know For example, we use AI in our quality assurance. It's enabled our QA manager to process more calls, which is improving our ability to service our community, and we can see noticeable improvements. Now we know that that AI assistance is paying off. It's doing what we want it to do, and we know that our risk reward of data management and data governance is providing a positive result. So we continue with it. And a lot of that is what we have to do is we have to find that trade-off. What do we want it to do? How do we define if it's doing it? How do we handle the data in between? Because we know that that data is going to contain that information. In this case, we know that data contains information, but we also know the company that we purchased it from showed us how they protect that data. And we found that their protection was FedRAMP grade, it was CJIS certified, it had all of the protections built in that protected us not only legally, but made sure that it protected us ethically so that we knew what they were doing with our data. And those are the things one thing that I'm very, very strident about, asking them, our vendors, how do you protect our data? How do you use our data? And teaching, let's say, the executives how to ask those questions, what questions are important and how to ask them, so that we can get, when they're negotiating with somebody, whether it's negotiating with me on something I'm building for them or negotiating with an outside vendor, how do you ask the questions that get to the core of how do we protect our data at the same time getting the most use out of it.
Right. Um, and can I ask, like more generally, if you had to create a list of recommended steps, what would you say were the steps to test and validate a model to ensure it wouldn't fail in the middle of a 911 operation?
Um, I always recommend stress testing. Get it, get synthetic data together to test it, and then just in the middle of your testing lab, hit it all at once. Hit it with everything you've got all at the same time. Stress it, make it work really hard, and see how it performs. If you see it bogging down, is it slowing down? Is the slowdown rate still acceptable? Are you still getting enough back that you can continue the time and seeing that it's giving you the accurate responses? That's the first step of testing. The second step is stress. Make it do everything all at once. And if it continues to perform well, then you have some confidence that when you're deploying it in a situation when the wheels have fallen off and everything happens all at once, that it's still going to be reliable enough for you to continue to operate. And we know that with the nature of our business, anything can break at any second. So as long as we know it can handle some of that stress and we can overstress it in test and it works well enough, then we feel confident that even if it breaks, it may break in an environment in a way we hadn't anticipated, but we know that it can still recover and come back to service quickly.
Right, right, makes sense. Um, Now, can you share a lesson from a project that perhaps didn't go as expected? Perhaps an AI model that initially underperformed, or a data initiative that faced resistance?
Yeah, I started building a AI assisted analytics platform, and I thought I had gotten all of my stuff right. I started in testing. First couple of tests worked well, and then I fed it a data set that was a little more challenging than I had fed it before, and it threw up, for the lack of a better descriptor. It just said, I got nothing. And it worked for 20 minutes on what I thought was a basic problem and said, I cannot create a solution. I unfortunately, I did that stress test in front of management.
Oh no. Okay.
Yeah. Lesson learned. I went back. I'm back at the drawing board. I'm redoing it. I threw everything out and started redoing it because I found it was also overly complex. What seemed natural and normal to me when I started asking them to poke at it and look into it, they couldn't get from step one to step three because step two wasn't obvious. So I took all that feedback in and said, we're going to throw this code base away. We're going to start with a new code base, but we're going to start with engineering in a different way. And I'm in the middle of that process now. And I'm really hopeful. I'm really optimistic that I have the workflow defined a lot better. So what I'm looking at is going to be not one global solution like I wanted, but micro solutions that will do different things inside the same framework. And I think that will work a lot better.
Right. So if I ask you to sort of pin down one of the most important lesson you learned from this experience, what would it be, and how has it impacted your practice and now moving forward?
Better user feedback. Because I am a very because I am a trained analyst. I have multiple degrees in it. I assumed that I could develop an analytics flow that would work for everybody and learned really quickly. It worked well for me, but it didn't work well for my target audience. And I failed to take my own target audience into mind because I assumed my target audience would look at my workflow and go, "Oh, that's the right one." And that wasn't what they wanted. What they wanted was something that was a different workflow. And I learned my lesson the hard way that the workflow didn't work for them. So back to the drawing board. And now I do a little bit more with I I reach out more often to power users because really they're my user base and say, okay, what do you want to see? Or do you want to see this? Or will this work for you? And pitch ideas from them, get ideas back from them, and that's building a better workflow. And
Right.
that's really ultimately the core of it. And it's the same in any software engineering. If your users aren't going to be comfortable using it, doesn't matter how many bells and whistles it has, doesn't matter how great it works. If they're not going to use it, it doesn't work.
Right. Yeah, that makes complete sense. Now we're reaching towards the end of our conversation, so I wanted to ask, looking ahead, what developments are you personally most excited about at the intersection of AI and public safety? For example, are there emerging technologies or research areas such as more powerful open models for forecasting, better simulation tools, um, or AI assistants for dispatchers, perhaps, that you believe could be game changers for emergency services in the next few years?
I'm excited about a couple different things. First and foremost, um, there's a lot of focus in the vendor community on bringing AI to non-emergency calls so that we can intercept them and take care of them without the telecommunicators that are manning our emergency lines being the ones that have to handle them. And now we're starting to integrate more of in the United States, we have a 311 program where it's things like there's a pothole in our neighborhood or the trash pickup didn't happen. In the past, people would call those emergency lines. Now we're fusing those together so that somebody calls in, that can be routed over to the right, whether it's a 311 staff or maybe it's even to a different department in the government structure that is more suited to handle that. So we're providing more efficient service to the public and reducing the amount of volume that our call takers are handling. So it really is a community win-win because now we can get those services that they need out to them faster. The other thing is, as my first degree many years ago was in linguistics. So finding better solutions to handle multiple languages. In the city I work in, we publish our city documentation in 4 languages: in English, in Spanish, in Amharic, and I believe it's Sudanese Arabic. So, because those are our major population sources. In another community, it may be they need things in Viet or in Korean or in Chinese or in French in Canada. That if we can do more with getting getting the translation service moving faster, because if we can get better quality translation faster so that we're not having to hold to grab a language line and grab an interpreter, that we're getting that mobile response out to someone in an emergency that many seconds faster, that can save a life, that can get somebody to medical treatment faster, that can calm a situation down faster. If we can do that, we're benefiting our community and we're taking stress off of our telecommunicators at the same time. And I think those are the most promising things: is how can we do those things more efficiently, quicker, and of greater benefit to our communities.
Right. And on the other side of this, are there any strategic changes that you think uh, would help resource-strapped public agencies successfully adopt AI-driven solutions, such as funding or open collaboration or anything else?
Funding mainly is the biggest one. Collaboration, the good news is that, especially in the AI modeling, a lot of our vendor partners are open to collaborating with us and making us a partner in the process of saying, if you will let us use your data in these ways, we can improve our product and we can roll those improvements out to you at a much more, at a faster clip. But it's mainly the funding. It's people rely on us being there, but they don't always see the funding that we need. We don't always see the funding that we feel we need to do as much for the community as we would like. So being able to have the right number of people in the seats, being able to have the funding to have our equipment up to date. We were talking about this a couple of weeks ago at a national conference, and we were saying people are expecting us to do 21st century things on technology bases that are 40 years old. So the more we can start leveraging better technology, better funding will allow us to do more with the technology we have, but will also allow us to move our technology goals forward so that we can engage with those partners internally and externally to develop the next set of tools so that we are providing better service. And ultimately, we see that we recoup that savings back into the community by improving our service without having to incur more and more greater costs. We can manage our cost to benefit ratio a lot better.
Right, right, brilliant. And that brings us to the end of this interview, Tony. Thank you so much for joining us and sharing your experience and insights from the front lines of public safety data and AI systems. And to our viewers, thanks for watching. If you found this conversation useful, don't forget to subscribe and check out the rest of the Deep Engineering publication ecosystem. We'd include links and descriptions to related issues and also the tools that Tony mentioned today in our discussion in the description below. Until next time, this is Divya for Deep Engineering.